we have the LCM here is 8. So this will be, let's first of all transfer everything to the left, everything from the right to the left. So this will be V1 minus V2 divided by 2 minus, remember V2 minus 0 divided by 4 is just the same as V2 divided by 4, minus V2 minus V3 divided by 8 equal to 0. So we are going to get the LCM from here. So the LCM will be 8. So 8 goes to 2 4 times. So this will be 4 V1 minus 4 V2. 8 goes to 4 2 times, minus 2 V2 minus V2, I am expanding this, opening the bracket, plus V3 equal to 0. Now we collect like terms. We are going to collect like terms. So 4V1 negative 4V2 minus 2V2 minus V2, this will be minus 7V2 plus V3 equal to 0. So this will be our equation 2. Next, we consider node 3. So considering node 3, this is node 3. We are going to consider KCL at node 3 to have the third equation. So just excuse me. So KCL at node 3. The sum of the current entering node 3 equal to the sum of the current leaving node 3. So looking at node 3 here, current entering the node, you have I3 is entering, I1 is also entering. Remember, I1 is the same current flowing through this resistor entering this node. So I1 plus I3 and 2IX is leaving. So I1 plus I3 equal to 2IX. So we are going to have I1 plus I3 equal to 2IX. We know I1, so we know I1, expressing I1 in terms of the voltage. From here, we know I1 to be V1 minus V3 divided by 4. So this will be V1 minus V3 divided by 4. And plus I3. I3 is V2 minus V3 divided by 8. V2 minus V3 divided by 8 equal to 2IX. We know IX already, which is V1 minus V2 divided by 2. V1 minus V2 divided by 2. So we are going to expand these to get the third equation. So this 2 will cancel with this 2. So we can now transfer everything to the left. This will be V1 minus V3 divided by 4 plus V2 minus V3 divided by 8 minus V1 minus V2 equal to 0. So now the LCM here is 8. So 8 divided by 4, we are going to have 2V1 minus 2V3, I am expanding at the same time, plus V2 minus V3 minus 8V1 plus 8V2 equal to 0. So we collect like terms. So this will be 2V1 minus 8V2 minus 8V1, sorry. This will be minus 6V1. Next V2. This is V2 plus 8V2. This will be 9V2. Okay. Next, for V3, we have minus 2V3 minus V3, that is minus 3V3. Okay. Minus 3V3 equal to 0. There's no other V3. So next, we see that 3 is common. We can divide all through by 3. So this will be minus 2V1 plus 3V2 minus V3 equal to 0. Let's make this positive. So let's transfer everything to the right. So this will be, this will be 2V1 minus 3V2 plus V3 equal to 0. So this is our equation 3. So we are going to solve these 3 equations simultaneously. So the 3 equations simultaneously, which we had in the beginning. So the first equation which we had was this equation which we had. So we are going to solve them simultaneously. So the first equation, let's bring all the equations together. The first equation was 3V1 minus 2V2 minus V3 equal to 12, equation 1. The second equation was this, 4V1 minus 7V2 plus V3 equal to 0, equation 2. And the third equation is this, 2V1 minus 3V2 plus V3 equal to 0, equation 3. So we are going to use Cramer's rule to analyze these 3 equations. So we are going to analyze these 3 equations using Cramer's rule to find V1, V2, and V3. So Cramer's rule states that the matrix AV equal to sum B. So A, the matrix A, so we are going to express this equation in the form of a matrix of this form. So this will be 3, this 3 minus 2, which is this term, the term of V2, the coefficient of V2, and minus 1, the coefficient of V3, and 4, the coefficient of V1 at equation 2 minus 7 coefficient of V2 at equation 2 and 1, and 2 minus 3, 1. Times the matrix V1, V2, V3 equal to the matrix B, which is 12, 0, 0. Now, to get V1, V1 will be equal to the determinant of V1 divided by the determinant of A, the A matrix. Now, to calculate the determinant of A, this will be equal to calculating this determinant, the determinant of this matrix, 3